All right, class, I got a couple of questions that came in for 2.6. Just kind of want to deal with those here just to make sure we understand this here. So we have questions 8, and then we got some other ones here going down the list here. So let's go for it here. I'm going to do each of these problems here, submit them. Hopefully I get them correct. And you guys can see how you're supposed to do them as well here. So this problem here, we start off, absolute value of 3x plus 3. Then we got a minus 1 from it, and then we have to be greater than or equal to 2. How do you solve inequalities with absolute value? That's kind of what we're dealing with right here. And so we're going to move this, and what I did is I copied it over to my PowerPoint slide so I can draw here. And let's go. So at this point we are going to move things across. So you have to get the absolute value all by itself on one side first before you do anything else. Then we split it. And on the notes here, you got to think about, is it going to be an and or an or? So let's go over here. If you have absolute value of something, it's going to be less than, or absolute value of something be less than or equal to. These two things mean you have yourself an and statement. Because what's going to happen is, about the number line, they're going to bunch up in the middle. That's what they're going to do. If you have absolute value that's going to be greater than some kind of number, or absolute value that's going to be greater than or equal to some kind of number, graph-wise what happens, you kind of get to something like this. They're going to go off different directions, and know you have an or statement over here. So that's really the difference. The difference is less than or equal to, greater than equal to. It'll determine the and or the or. So going over here, this guy is going to have to be an or statement on our hands. So the way the book does it is you get to drop the okay. Let's keep on going. And so that erased a few things here. So less than some kind of number, and the absolute value less than or equal to some kind of number. That's going to be an and statement. Absolute value of something, that's going to be greater than some kind of number. And again, the number has to be a positive, less than or equal to some kind of number, that's going to be or. So looking at this guy here, that's the or statement. The way the book does it, it takes off the absolute value, switches the inequality around, puts a little negative there. Oh, and then it rewrites the problem itself exactly the same way except for the absolute value number. And again, if just more detailed information, you have to go to the lecture notes for that. Anyways, let's go for it here. So subtracting 3 from both sides gets you a -6. Dividing by 3 gets you x less than or equal to -2. Or subtracting 3 from both sides here gets you a 0, and that's okay. We still have x to simplify, so x greater than or equal to 0. So let's take a look at a graph. What does a graph of this look like? Looks like we have a block at -2. We're going off to the left because the less than symbol. Then we have another block happening at 0, and we're going off to the right. So as far as interval notation goes, I think we go like this, from -infinity to -2 with a bracket, union, bracket at 0, off to positive infinity. Let's see if that is going to give us the answer for this one. So interval notation, there's interval, so I'm going to go from, I think it's going to be like this, right? So infinity to bracket, and we put it in. So we go from -infinity, shift over by arrow keys, to 2, union, and we're going to go 0 to positive infinity. That's what we're saving there. And again, exactly what I want over there. And then this one, kind of careful on this one here. This one does open dot, close dot. So we have ourselves a closed dot at -2. And you have to hit it right on or else it's going to be wrong. Oh, can't do a dot, sorry. Clear it out. You got a line segment. I'm going to do a line segment. Okay, let's do the dots first then. Dot there and a dot there. Okay, you got to be very, very precise. You got to be right there. Okay, then we're going to do the line segment going off to the left. Another line segment going off to the right. All right, let's see if we got this correct. Submit it. Half correct. Ooh, I know what I did wrong. Should have been a -2. There you go. That's what I wanted. And submit. Yes. Okay, forgot the little negative there on my answer here. Okay, so that's number 8. I had another question for number 12. Jump to there. And similar to what we've just done before, it's absolute value 2x plus 5 greater than 8. So let's go back to our slide over here. It's greater than symbol, so it's this one right here. So it's going to be an OR statement as well. So I built it already inside here as well. So I'm going to start solving this one. All right, OR statement. Again, same thing as we did before. It's going to be no more absolute value. Switch the inequality, make it a negative, or just the absolute value by itself and everything else remains the same. Those are two different pieces. All right, so let's go with it here. How is this more difficult than the previous one? Is that we have to graph fractions here. That's what we're looking at. We're looking at, let's see, 2 goes into 13 6 times with a half left over. So we're looking at -6.5. And this one, as we do this here, subtract 5 from both sides, gets you a 3. Dividing by 2 gets you, looks like 2 goes into 3 once, so 1.5. So make I think on this here. So at -6.5, we have a parenthesis going off to the left. At a positive 1 1/2, we have a parenthesis going off to the right. Interval notation will look something like this: negative infinity to negative. You know what? And because it's a, we don't have to graph it technically. We can actually keep it like this. We keep it as an improper fraction. In algebra, we technically like improper fractions. Going back over here, starting interval notation again. I'm going to go with parenthesis to parenthesis. Negative infinity, 2, and this one requires a fraction. Let me go back just to make sure it's -13 over 2 union. Same thing here. And fraction 3 over 2 to a positive 1/2. Save. Voila. Is that what I want? Yes, that's what my answers were looking like earlier. And submit it, and let's see what we got. We got green. We're good. Okay, let's keep on going. 13 is the other question that came in. And so this one, just kind of careful on here. It's same as the previous problem, except for a little negative right here, because a little negative is going to change a few things for us, okay? So, right, I'm going to jump to my PowerPoint slide, which I've queued it up already. There it is. Let's solve the problem. So, OR statement. This is because of what? Because of 2 slides ago. It's going to look like this again. Absolute value being greater than a kind of number on the outside. Absolute value being greater than a number on the outside. So we split it off, 2 different pieces with an OR. So how does this work? -4x minus 3. It's going to be switching of the inequality, changing the sign on the number on the back side of it. Then the other one's going to be same exact thing, just drop the absolute value. Okay, with that in mind, let's go for it here. So it looks like I'm adding 3 to both sides here over here. a negative 4x less than negative 5, dividing through by a negative 4. And don't forget, here's why this problem is. Here it is. You got to switch the sign on your inequality. It stays as negative 5/4. 4 comes down. And we go the other way here now. So adding 3 to both sides gets you an 11. Dividing through by negative 4 would get you an, again, we're dividing through by negative, switch the inequality, and negative 11/4. So we're looking for that. And let's see what we got here. So that means this is the smaller one, right? Negative 11/4 would be smaller than negative 5/4. So it looks like negative infinity to negative 11/4, parenthesis, union, parenthesis, negative 5/4 off to positive infinity. Let's see if we are correct. My little button here, intervals, I'm going to use this one. So negative infinity to a fraction called negative 11/4. And we got ourselves a union. Again, same thing here. And that's going to be another fraction called negative 5/4. Past the parenthesis, past the comma on the other side, so that we can go to positive infinity. Save, and let's go back to make sure that's what I have here. 5/4 there, 11/4 there. That looks exactly how mine looks. I think we're ready to submit. Got an extra parenthesis in here. How did that happen? Let's go on the preview here. I'll go back, look at my math here. Oh, there it is. This should be a positive right here. There should be a positive. And that should be a negative, so this should be a positive answer right here. Okay, let's try it now. Let's go inside here and just change it to a positive right away. So now let's see if we get it correct. And we should. There it is. Those negative sign, positive signs sometimes gets everybody. All right, let's go to this one here. All right, this is a less than or equal to symbol. Negative inside there, you're not going to be switching. Hopefully that will make sense there. So again, I have it queued up over here already. And or, going back to our little list here, it's just like this one here. All right, and that makes an and statement. So that's an and statement. Let's go for it here. So we're going to split them off, two different pieces, and means it's going to have to bunch up in the middle for it to be the right answer. So according to the book, we're going to go with, we can go like this, and let's talk about it here real quick here. We can go like this, and we can go like this, and that would be perfectly fine from the previous ways. But your book says, look, don't do it that way. What you should do is you should do it the short notation. Short notation says we're just going to stick the -6 on the other side, and we're going to work it this way, and that's called the short notation for and. Hopefully you guys remember that from the previous sections. All we do is we just work it on all three sides at the same time. So So negative 6 plus or minus negative 4x less than or equal to 10. 10. Divide through by negative 5, divide through by negative 5, negative 5, and that makes a positive 2/3. And then you say, but Mr. H, hold on. Doesn't that change? Absolutely. This has to change. That's an x. This changes as well. And that becomes a negative 2. Now, you can't graph this because remember, for graphing short notation, they always have to have a less than or equal to symbol or a less than symbol. So what we're going to do is we're going to switch this all the way around. Imagine just flipping it around. So negative 2, flip the sign, flip the x, flip the other sign, and flip the 2/5 to the other side. There it is. So it looks like we have a bracket, negative 2, or our minimum starting point is negative 2. We'll go up to positive 2/5 and a bracket there. So that's what it looks like our answer is. Let's see what we got. So we have interval notation, which means bracket, bracket, starting off at negative 2, going up to a fraction of 2/5. Save. That's what I want. Let's just go back over here just to make sure that's what I have here. Yep, negative 2 to 2/5, negative 2 to 2/5, bracket, bracket, submit. And we got the right answer. Okay. All right, so hopefully that would help you here on the rest of the questions for 2.6.